So today we are going to discuss with something called as summary function. So please type this everyone, hashtag summary function, and let's create one kind of data which is, let's type here, create uh, social data frame. Okay, just we'll create this one, create social data frame. And let's create the variable called as ID where we have C and just put number from 1 to 8 here. 4, 5, right? And then just press Control Enter. Then followed by you can type your gender, which is one of my vector I'm going to create here. Then C, open the bracket. You can take it as any information. You can take it male, female. Okay. Then you just type it as female, and then you can take it as male. Total 8 observations we have, and that we should like get all the information. Okay. So just create this one, this information. I hope you are done.
Sir.
Yeah, perfect. So now let's do it. Control Enter for this. Then you can take it as weight. It's one of the variable. I'm going to create one more weight. I'm going to take here. Let's type these numbers. Yes. Okay. Okay. And just let's take the variable called as weight. Then once weight is created, we'll take it one more variable called as height. So let's write the number 1.83, comma 1.75, comma 1.57, then 1.65, then comma 1.94, 1.85, then 1.53, and 1.62. Just take these numbers, Control Enter, then you can take it as cholesterol. This is another variable I'm going to create. C, open the bracket, 15, comma 18, 25, 30, 40, 32, 23, 28. Then let's take one more variable, last one, that is your income. We'll take it here, income. So what is the income? Again, put C, right in the bracket numbers, 15,000, comma 20,000, then 35,000, then 12,000, 50,000, 8,000, 60,000, 9,000, right? Then let's give the name for this one. I'm giving name as social data. C, open the bracket. Okay, C data dot frame. Okay, just open the bracket. Then let's write down the variable we whatever we have inserted. That is first is ID, then gender. Okay, gender capital G I have put here. Then we can put it as a. So we have one more variable we should have created. Okay, but let's not worry about this one. Gender, then you have weight. Okay, then you can take height. Then you can take the next one as cholesterol. And then finally you can take income. Okay, so just press Control Enter. This is your social data and just type social data, Control Enter. So I hope you got this one output like this. Did you got this one, everyone? Please let me know in the chat box or in the, you can speak opponent. Just type social data and you will get this information.
Got it.
Got it? What about, you can raise your hand. Arun, Janvi,
Got it, sir.
and Nitya, you got it?
Got it, sir.
Yeah, fine. So let's do it. The next code. If I want to run this code, particularly the basic statistics, okay, for this. So just type summary social data and press Control Enter. Summary, okay, and just type here Control Enter, bracket open, social data, that is a variable we created, vector. So in this you have something called as ID, gender, okay, then you have weight, then height, cholesterol, okay, just I think there's income, okay. So this is what we created with the help of summary, which is not complete statistics, but this is give some basic statistics, which is given through your measure of central tendency. Let's say, for example, if I want to know only for income some statistics, so we can type summary social data, we can create here and then put dollar sign. And let's say for income, I just want to know the basic statistics. So just you can type summary social data dollar sign and then you can use income. So you will get the median, minimum you have income of 8,000 and maximum income is 60,000 followed by median and mean. Okay, that is what we got from this particular data set here, right? Let's go on to the next one. Shall we move on?
Yes, sir.
Yeah, perfect. So let's go to the next one. Now, what I'll do, this is very common statistics we are getting from summary. Summary is mostly not used much of the time, but it does not have all kind of information related to your descriptive statistics, right? So for that, we need to know further skewness, kurtosis, coefficient of variation, then confidence interval mean, sum, and many things we want to know from the data, so that we are not getting through summary function. So we can do one thing, we can install packages. Okay, let's run this code. Install packages. There is a package called as Pastec. Okay, please just type this code, install.call packages. Make sure you have connected your system with the internet. Okay, then press Control Enter. We'll run this package, and once it is completely run, this package will do something called as library. Okay, this package name we have to type here Pastec, then press Control Enter. Then you will get one warning message, which is not an error. Just try to understand. It's a giving warning message about that particular package. So that is what we done library. So now one more thing we have to do something called as we will install one more package called as install.package called as boot. Okay, so let's do this particular package install control. Then if you ask here, do you want to restart R prior to the install? Yeah, just you can click yes here. Okay, just you can put install.packages. Okay, this is a boot package we are installing here. So once it is installed, okay, after that what you can do here, you can get automatically, you will get blink the cursor in the console. So there you have to just type after that library, okay, and type the package name called as boot. Okay, this is your package name boot. Just press Control Enter. So it will take out the information from that boot library so that whatever we need that is taken from here. Okay. So now I think we are ready with many of the things to do analysis from here. So just you can type here stat, okay, stat dot desc. Okay, just you can type here and let's see whether we can run this particular data called as social data is okay, and just press Control Enter. Okay, so there is some install library patch tag. Okay, so I think we need to run this code once again. I'll just run this patch tag once again, and then boot. I'll run it once again. Start. Ah, then I think you will get this package called as start.disk. Okay, there you just type your social data and then press Control Enter. I think you will get this result, very important result for your analysis. So you can see here, okay, from this particular data. So I'll just make it bigger one so that you will get to know some more information. So can you see here, everyone? You got NBR dot value, NBR dot null, NBR dot NA, minimum, maximum, range, sum, median, mean, standard error of mean, CI, that is confidence interval of mean at 0.95, variance you got, standard deviation you got, then coefficient of variance you got. For all the variable you got except gender, because gender is a text data over here. So whichever is a numerical, you got all the values here. Okay, so very important result. Let me know how many people you got here, this kind of
Got it,
data.
sir.
Okay, Nitya has got, Viva has got, perfect,
Got it, sir.
right.
Got it.
Yeah, perfect, perfect. So this is now you tell me what is NBR dot value. NBR dot value is nothing but the NBR stands for number of value. So you remember in our social data, if you just scroll up and just see here, so you have total how many observation you have? 8. So how do we get to know? You can just type str. You remember this function called str, just type social data, press Control Enter, you will get total 8 observation and 6 variable from your data set, right? So you see these are the variables we have, total 6 variable, ID, gender, weight, and all, followed by this one. That's very important how to generate the result from the statistical model. Then look at here, what is the beauty of this stats dot disc means describe. Okay, this ESC means describe the social data. That's what it's saying. You have variance and then you have standard deviation. Two's the square root is 2.44 and coefficient of variation is 0.54. So basically coefficient of variation is nothing but we usually take standard deviation divided by mean, right? That is the what we take. So every 1% of if you turn in terms of finance, how do you interpret the value of coefficient of variation? So to take 1% of returns, what is the risk you're taking, right? So very coefficient of variation, which is less, that particular information will take it for analysis. Okay, it's a very, very important result what we got from this particular data set. Okay, so one more thing we can do, the another way of doing this particular getting the result of descriptive statistics completely, we can install one more package called as PSYCH. Okay, this is one package, PSYCH. Okay, this is one package you can install. Just type this code 137, install dot packages PSYCH. This is one package which is used for calculating descriptive statistics. Let it run for a while, then you can see after that it will automatically it will show you whether the result is, you can see if it is red means the R is still running that particular package, it is installing. Okay, don't do anything in between this because otherwise it will interrupt the installation of the package called as psych. Okay, so let it get installed. Once it is installed, we can library the particular package. Okay, so based on your internet speed it will try to collect the data and install it. Okay, so I think it's almost done, so we can do it now. Further, still some more going packages getting installed. Please run this code install.packages called as psych, PSCYH CH. Okay, is it clear?
Yes, sir.
Then once you've done this one, please do the code library PSY. Just run this particular code and you can see attaching pack. Okay, so that is what we'll get here. Now what we can do here, just we can run this code. Describe if you just put here, okay. Describe if you put, so okay, there is something for fetching key, it's showing error. Let's me put as describe. Error in fetch key, okay. I just want you to run the code, describe. Okay, just take it here and just type here social data and press Control Enter. Okay, so did you got like this data information? If you
Yes,
run
sir.
this, you will get like this, very important. Now you see how the way of getting the output is very different, and but the all the results are same only, but way of generating the output is very important. Here you can see here you have variables, you have mean, you have standard deviation, you have median, trimmed. After that, what is the value? MAD is mean absolute deviation, minimum is there, maximum range, skewness, and followed by kurtosis and SE, that is your standard error, right? So you can see all the kurtosis value of this particular variables are all in negative. Skewness value, if you are positive, if you are very negative, but the skewness is very very low in all the cases, right? So this is what we are able to get the output from that particular source. Okay, that's a way of getting the output. So that is way of collecting through describe, right? Okay, so shall we proceed further? Did you
Yes,
got,
sir.
Yes.
how many
Yes, sir.
people got this one? Okay, perfect. So all of you got. Let's do with the another way. Let's now, the moment when I type describe social data, it is describing the entire variable into statistical thing, right? But I suppose, for example, if I don't want to describe the entire statistical, I just want few variable to be described. So how do we do that one? Let's try to run this code called as, again, we'll type it here as describe. Okay, describe, open the bracket. This might be it has not installed got properly, but you can still use describe, open the bracket, just type here social data. Okay, and then you can just put one variable. Let's say I'm going to put gender. So can we describe gender in this particular data set? Can we describe? Okay, let's see whether gender will come or not. Then press Control Enter. I think it's not coming, but we can take it another variable called as describe. Okay, we can take it social data. Okay, and then we can take it. We have income, right? We can take it income. Okay, so and then if conditional should be greater than one. Okay, so there is something is missing here. Let me come to this gender and just let me see whether we can rerun the code. Let me run this the code describe. Okay, you can just take it this describe by describe dot by. You can just run this code describe dot by. Social data, then just put, let's see, gender. Will we get it or not? So yeah, I think we are getting few information here. Yeah. So did you got it now? Just run this code. I think this is not executing. I'll just delete this particular code. Run code number 140. Run the code number 140. Describe dot by you can put here. Describe social data in that you can run as gender. You able to get it?
Yes, sir.
So now you can see here it has grouped by female, okay, and then you can see again it has given for female, okay, this is grouped by female and this is grouped by what? Male. So can you see there are two data it has created. One is it has created by gender. So there are two genders we have described. Remember, we have described male and female, right? So based on that one, it has created the statistical analysis over here. Okay, clear?
Yes, sir.
Yes, sir.
Okay, so that is what you need to understand here. Let's go to the next concept here. So all of you got, please raise your hand. Who has got? Okay, fine, perfect. So all of you have got this one. So now let's go to the next concept now. Okay, under this only we'll run in other way. So I'll teach you one more package called as Stargazer package. How do we use this particular Stargazer package and what is the importance of this package we can understand when we get some kind of analysis. Okay. So please run this code now. I'll just teach you one new package called as Stargazer. Okay. Just type here hashtag. Everyone has to type this one now. This is a new concept here. Stargazer package, which is again used for many kind of analysis we can do with the help of this one. Okay, let's do Stargazer package. Type this 141 code. Now let's first you have to install this package. Okay, and so install dot package. Okay, just you have to type here star. Okay, gazer, Gazer. Okay, just run this code install dot package. Okay, and then you have to type stargazer. Okay, just press control enter and let it get installed. Okay, this particular package, let it get installed. So once installation is done, so we can go ahead for running this particular package. So once you install any package, remember you have to do something called as library. That is very important. So unless library you don't do, you will not get the result of this. Okay, so just type install dot packages. So now I think we are ready with this. So please type this code called library and then you can run the name of the package. You have to type library bracket open stargazer, press control enter. Okay. So you can see here, this particular package has been done library, and this is the latest version under this it has given, and it is the citation also of this. So this is basically use particular package developed by these two people in 2022, Avlak and Marek. And many times we use Stargazer for running regression also, and for summary statistics table also. That's the beauty of this particular uh, Stargazer package. Okay. So now we want to have some data set for this one to run this one. So what we'll do now, so we'll create one kind of, I will show you one data set where we have already, I hope you remember, all of you, in my first day of class, I was talking about one data set called as empty car. Just type this code, data set, okay, empty car plus control enter, and then you can see here this particular data set, which is nothing but related to car models. Okay, so now there are something called as mpg is there. These are the variable. Cyl cylinder is there. Okay, if you just want to know what this information talks about, you can just take the help of this particular package data set name. What is empty cars? Okay, you can type on the right side and you will get to know. Okay, what is mpg? You can see here there is something called mpg. I hope you can see. Okay, did you got this one, everyone? Kindly let me know so that I can start doing this one.
Got it.
Yes,
Got
sir.
it.
How about others? Everyone got? Chetan sir, Janvi, Nitya?
Yes, sir.
Right. So now I'll show you first. I will introduce with you this data set, okay, and then we'll go on to the process further. MPG stands for, you can see here, MPG is nothing but miles per US gallons, or okay, that is MPG. And the next variable is CYL, that is called number of cylinders, okay, and DISP is nothing but displacement. And then you have HP is called gross horsepower. Then you have drag, that is called rear axle ratio. How much is that? Weight is there. Cusack is there. WT means weight. Okay. Cusack is nothing but 1/4 mile time. Okay. Quarters. Then you have VS, that's called V-shaped engine, or what type of engine it is given, the straight or V-shaped. Then AM is nothing but transmission, whether it's automatic or manual. And then gear is there, okay. And then CARB is there, carb, uh, which is called as number of carburetors in this particular vehicle. So this data set has a lot of information which talks about the vehicles. There are almost, if you want to know how many vehicles are there, just type this string, okay, and just type in the bracket empty cars, press control enter. You will get to know there are 32 observations and 11 variables are there. Okay, so now let's try to understand. We can form one kind of uh, from here something called as dependent and independent variable. Okay, so let me take few variable from here. Okay, just take mpg, hp, and weight. I'll take for your understanding. Okay, I'll just go to my excel sheet here. I'll just scroll down and just I'll take new here. Okay, so our data set name is what? FD cars. Okay, here you have something called as mpg. Okay, and then you have, I'll take few variable from there. HP you have, then wt is there. Okay, this is called as miles per US gallons. Okay, that is what they have given here. And then this is your gross horsepower. That is, I'll just write it as horsepower, and WT is nothing but weight. Okay, so now let's try to form one kind of equation from here, and we'll try to understand from this data set what this variable talks about. Okay, so when we talk about any kind of equation, so we know, right, y is a function of x variable, right, which is considered as y is my dependent variable. So I'll write it here, dv, this is my dv, and x is nothing but your iv, that is called as independent variable, right? So now from this data set you have mpg. Let's understand, this is your miles per gallons, or we can say mileage also per gallons, how much it is giving that particular vehicle. We have hp and you have WT. So as of now, I have three variables, which one among them is your dependent, one is independent, and let's see how many are independent here. So can you just tell me from this particular data set, what is your dependent and what is your independent? So among these three, you have to tell me when we say who is depend on whom, either HP horsepower is depend on mileage, weight, or MPG miles per gallon is depend on HP weight, or weight is depend on HP and miles per gallon. Can you just try to find form a equation here? Can anybody tell me what can be your Y and what can be your X here? Okay, yeah, so I can see in the chat box. So there is a MPG is equal to HP plus weight. Yeah, perfect. Right. So what we can assume from here, we can, because any vehicles you see, their mileage is depend on the horsepower and weight, right? So we can consider MPG as my Y variable, and you have something called as HP, and you have something called weight as your X variable. So we can write it here as Y is equal to, okay, you something a function of, so here you have two variable independent. You have x1 comma x2, which are two independent variable. So it means your MPG is a function of your HP and your weight, right? So that is the meaning of this particular data set over here. So now we can just see to that how do we calculate this particular data set descriptive statistics from the information. So I just want everyone to type this code. Stargazer, that's a package we installed, and then you can type empty cars. Okay, just wait, just hold on. Before that, I'll just run this code. You attach this particular data set so that it will be easy for us to take every time. So attach empty cars, you just run this code. Attach, open the bracket, empty cars. Okay, then you can run this code called as Stargazer. That's a package which we install here. And then empty cars. Okay, then comma type is equal to, now we want that type to be in the form of text. Okay, then comma, and the title of this particular information result should be in the, we are giving a title, or we can say heading for this will be descriptive statistics. Okay, this will be my title for that particular data set here. Okay, then you can just put comma digits dot digits, you can put digit is equal to, so this means it is talking about how many integers that should be kept in the form of decimals, or we can say that indicates how many decimal place should be kept there. That's what we are talking about. Digit is equal to 1. Okay, then press comma out is equal to, we are putting in the form of table, so you can just write as table dot txt. Okay, this should be a code. Okay, just run this code and let's see what is the output we are going to get from this one. So just stargazer. Okay, and then you can just click run. So I think you will get the output like this, and mean, standard deviation, minimum and maximum, and then you have lot of information from this particular table over here. Clear? Are you getting everyone?
Yes, sir.
Everyone got this output? Right. Now let's try to understand what is the meaning of this one. What is N here? So the N is nothing but your total observations. We have 32. Okay. So that is common for all. Then mean. So mean value of MPG is 20.1, standard deviation is 6, minimum is 10.4, and maximum. So it means among the vehicle, whatever the vehicle you have. So these are the vehicle name, Mazda RX-4, RX4, WAG, Datsun. These are the companies who are having, you can see there are familiar names are there, Toyota is there and all. So if you just read this data, no, you will understand that the mileage on an average of all these vehicles, if you see the average miles per gallon is 20.1 with standard deviation of 6 and minimum mileage they're giving 10.4 to the maximum they are going around 33.9. Okay, so that's a mileage per gallon. If you see the cylinder mean value is 6.2 and followed by like this, right? So very easy to get the information in the form of table.txt, that's text. Okay, this is what we got from the descriptive statistics over here. Okay. So now let's do the another way of this particular. You can see heading is given as descriptive statistics. So what we can do again, just we'll copy this code, the previous code. Okay, please copy everyone the same code here and just paste it down here. Just paste it down. The few things I'm going to change it over here. I'll keep it few things same and few things as change. After txt, what you can do here, just you press it here, just type flip is equal to, okay, and just type here true. So flip is equal to true. So now let's see how the data looks here and what exactly will happen from the output. Okay, the code will remain same till table.txt, but after that you have to type just flip and let's see how the data will look here. So now can you see here everyone, is your data got flipped? Now what difference you found here? Can anybody tell me? In this output and previous output, what's the difference? First of all, let me know how many people got this output.
Got it, sir.
Got it?
What it, sir?
Okay, so now can you tell me what's the difference here between the previous and the current output? Any difference or you find the same only observations from that perspective? Table is transposed. Yeah, those which are where in the rows have become, yeah, rows has become column, and that's what we do in something called as in Excel, say something called as flip concept we use in the form of transpose, right? So that's what I use, flip is equal to true. Yeah. If it is not, then by default it will take in this format. Okay. So that's understanding of this particular data set. Okay. So let's do the next one. We'll run few more on this particular output. Okay, so what we'll do, please run this code along with me so that we can get some more information from Stargazer how to use this particular data set. Okay, just type Stargazer. Okay, open the bracket, you just type subset. Okay, just take subset, open the bracket, you can type here empty cars, that's the data set name, and okay, then put bracket, open C. Then I'm going to take the first variable, dependent variable as mpg, and then few other variable I'll take it as hp. And remember unknown variable I took it as I think weight I took, right? Which are for my just reference out of these three variable. So I'll just come out of this bracket and just press comma. Okay. There you can type it as empty cars. Okay. Then you put dollars vs. Okay, 2 time double iterative 0, then close the bracket. Then you can type it title, which we are going to give, that is your engine type. Engine type, we can give that as my title. Okay, double inverted. Okay, press comma. After that, you can type it as type. Okay, is equal to, again, we want this information to be in the form of text. Then press comma. After that you press comma and we'll keep it digit as 1 only. Okay, digit is equal to 1. Then you can put comma, out is equal to table. So the information should be represented as table dot 3 txt. Okay, so code is little bit lengthy, I'll just share it in the chat box. you can just take this code, okay, and just paste it in your R Studio and just run this code. Okay, so there is some error is coming here, MTC valid. Okay, we have represent here VD. It's not VD, it's VS. Okay, just put it as VS and just run this one. Okay, again, there is some error here coming. Let us see what is the error here. So unexpected symbol in stargazer. Okay, so you subset empty cars, CMPG, HP, DRAT. Okay, empty cars, dollar VS engine. Then you can VS. Then I think we are not put comma here. Okay. So comma title, engine, type, then press comma type is equal to text, digit is equal to 1, out table dot txt. Just run this code. I think you will get now. Okay. So I think you will get this kind of output. Just check your code. Okay. I'll just share with you the revised code. What went wrong in the previous one and this one. Just there was some comma was missing. I told you R is very sensitive. If you miss comma or any kind of bracket, full stop, it will throw you the error here. Okay. Just run this one. I think you will get the output. And this is only for those three variable we have defined MPG, HP, and wait for that. It has given the statistical result with heading as engine type, mean, standard deviation, minimum, and maximum. Are you able to get it?
Yes, sir.
How many people got? Can you just raise your hand so that I'll get to know? Did you got the
Got
output?
it, sir.
Yeah, two people has got. Okay, three. Fine. Anyone? Right. Shall I proceed?
Yes, sir.
Perfect. Okay. So if you want few variables descriptive statistics, then you can get by taking the subset function. Okay. Just you can use this function called subset. Okay. Now let's do another way of doing by one more package you have for doing descriptive statistics. I'll teach you one more package. Just type the everyone install dot packages. You can type this summary tools. Just run this package summary tools and just press Control Enter and let it run. Summary tools will the next package name after Stargazer. Okay, then you just run library. Just run this code library summary tools. Press Control Enter. Let it library do it. Okay, it's still happening. If there is a red means just don't interrupt the R. Let it happen. Library. Okay, I think it's done now. I think we can start this one. Have you installed everyone so that we can proceed with the next code? Clear? Nitya, Vibha, Janvi, Chetan sir, Arun.
Yes, sir.
Did you install? Make sure you connect
Sir.
internet, okay, while doing this package installing. That's very important here. Okay, so now just let's run this code. So we have installed the package called as summary tool. So you can see here, just you select that particular uh, option called as summary tools, and you type here DESCR, open the bracket. What was the recent one we created data? It was social data, right?
Yes, sir.
Just type summary tools and two dot, okay, describe social data and just press Control Enter. Look at the result, how it is giving the R program. Can you see here? So this is where exactly how we get particularly when we do any kind of descriptive statistics, when we do run Excel and all. So see here, there is no problem of selecting the rows column how we have in Excel. Just run one code. You will get the entire descriptive statistics, skewness, kurtosis value, everything into one particular code here. So that's the beauty of this particular chart, what we can say here from the Excel, right? So that is how we use this particular code. So you can just see here how we can just take this result in Excel and you can use for your interpretation. You can just later on you can just copy and paste, or there is another code is there where you directly get the output in Excel form also from R also. But just one code will give the entire result in this particular form of table, right? This is very clear now. So what is the mean of cholesterol is 26.38. The height is 1.72, 4.5. Income is 26,125 and weight is 67.5, right? Okay. All of you, I think you must have not got some of you. Okay. You remember one more we created yesterday, one um, in our discussion when we were doing yesterday in the previous session, our first day class, you remember we created one something called as one data set which was there already we created. Can you just remember what was the data we created first day? We created one data. Let's do the summary for that particular day. The first day where we had something called as uh, we created data. What was that? Can anybody just tell me so that we can run that particular? You remember when I taught you my data, data dot frame, all this concept. Okay, can you just work on this one and just type your disk and just type your my data and just press Control Enter. I think you may get this result over here. So this is ID and weight, right? That is what we created, skewness. But when we do summary, you won't get skewness and kurtosis value here. So there is a skewness of zero point 0.0 in ID, but there is a negative skewness in case of weight. Okay. And then I gave you one assignment over here. So that assignment was related to particularly what exactly you created. That also you can apply. Let's imagine if I'm putting a summary, okay, and if I'm typing your tools and I'm telling you to describe the R, let's say I'm creating today's data called as BMI body mass index. You can just run this one and you will get the entire summary of this body mass index, age one, height, weight one. This is what we got from the result of the previous one. Clear, everyone? Are you getting everyone?
Yes, sir.
How many people got? You can do it on your score sheet also, whatever the assignment you did, you can just apply on that. You will get the entire summary here. Are you getting everyone? Hello? Yeah, because you were not there in the BMI. I think when you created that one, you can just apply on your assignment what you can have done that one.
No, No, sir, I actually did it. I did it for my data and BMI. Both I have done it here. After that, I did the assignment.
Okay, so
I'm
it's
not getting for both, sir. My data and BMI. For both, I'm not getting it, sir.
okay. Just see that bracket whether you have missed any the type of what you have created, B capital, small, or
It's
whatever.
correct, sir. It's correct, sir.
Okay, what you can do, you run library once again. Just click on
Okay.
library. You can run once again. You will get the output of that.
Okay.
Yeah. What about others? Did you got it?
Yes, sir. Got it, sir.
Yeah. So let's do that's a very important. So this is how descriptive statistics works on this particular, uh, we called as package called as summary tool. So I taught you Stargazer package, and I taught you previously a few more package related to descriptive statistics. Now let's do one kind of frequency table concept here. Just we can type everyone frequency of the variable, and let's see whether how it will work on the R program. Frequency of the variable, and let's run some kind of summary tools of this one. This is very important tool, that package summary tool. You can run a freq means it's talking about the frequency, and then you can talk about any variable. You can take it here. So for example, I'm taking gender. Today's what we create a bracket, open gender, and press Control Enter. Look at the result, how it is giving the R program. So it is created the frequency table here. Remember, we in gender we had male and female, right? Total 8 observation we have. There are 4 female and 4 male are there. So obviously it is a 50%, 50% of information of male and 50% information of female we have. This is what the frequency table we created. And if you want to do frequency table of any other data also, you can run, just type frequency and then open the bracket, and then you can run for the frequency for your age also. That is one variable we have. Yes, you can run and check it. So frequency table for the age, let's say for example, there is a age of 25, and based on this, it has created one. And what is the percentage of the age frequency contribution over here? You can same way you can run for the frequency for your assignment also, which you have created already. That also you can check it and understand what is the basically and the use of this particular table over here. Okay, is it clear?
Yes, sir.
Are you able to get the output? Okay. Let me show you one more thing. Summary of the data frame. You can just type here. Summary of the data frame. Okay, this is another way I teach you a concept here. Just you can use one more, the same summary tools. You can run here and just type DF summary. Look at the result now. I think BMI you created now, and just run BMI bracket open summary, and then you will get one result. Okay, and I think I'll show you the result. Look at the result, how it has given. This is DF summary of BMI, the entire body mass index data what we created. For that, it has created the summary starting from age, weight, then numeric, then height, and then again numeric. And you can see here, if you look at this particular data, I'll just take it on right side. You will get now very clearly. Okay. I hope my screen is visible properly. So you can see mean value, and in the bracket, whatever is there, that's your standard deviation. So mean is 40.5, standard deviation is 17. And then frequency calculation is there, percentage of valid, what is the percentage of each information over the age. And then you have age, what is the number which is given from minimum to the maximum, and the median age is 33.5, interquartile range of it is 20.21.2, and coefficient of variation is 0.4. right? And you can see here it will give you the wonderful result of related to whether there is any missing information is there or not. So from the age there is no missing, that's why the value is 0, and here it is 0.0 percentage. Okay, same way you have weight here, which is numeric, right? And age is also numeric variable. You have mean of 65 and standard deviation of 16.4 and followed by height, right? Are you getting this result, everyone?
Yes, sir.
Sir, what is the graph there?
Actually, did you, yeah, this side, do we have graph? We got not, right? So it is showing the weightage of each one over this. Okay, so that is 3331, just like your cumulative frequency kind of concept, that is
Like tally marks, how we put
tally
when we
marks, yeah, kind of this one. You can work on your assignment also, your assignment data. You can just type df summary and you can type what was the vector you created there. You can just run and you will get the result over this. Clear? Shall we proceed next one? Other way also I'll tell you.
Yes, sir.
Okay, fine. Let me go to here. Just take it on the right side. Yeah. So let's go to the next concept. Okay. One more package I'll teach you here. That is install.packages. Okay. And just run this code, all of you. TABLE table1. Okay. Just run this package name called install.packages table1. Okay. Then you just run this code library and table1. Okay. And then press Control Enter. Then let's go to the concept of that empty car. I'll take it here for creating descriptive statistic in the form of table1. So this time again, just remember how we were doing summary tools. You have to take the same way, table1 semicolon 2 times colon, and then you just write here label. Okay, just write here label bracket open empty cars. Okay, I'm just taking an empty car dollar. If you put dollar, you will get the variable name. I am taking MPG. Just select MPG here. Okay. Come out of this bracket, less than this hyphen. Then you type here miles per gallons. Okay. Then just press Control Enter. Done. Is it clear? Next, again, one more. We'll create table1. Okay. I'll take it here as a label. Then that is LEBL label. Okay, open the bracket, empty cars. Then again I'll put dollar. I'll take another variable called weight. Come out of this one, put hyphen dash, WT weight of the vehicle. We'll write it, give name as, then press Control Enter. Then we'll create one more table1. Then label, open the bracket. Then you can type empty cars. Okay, again put dollar sign. And remember, I think we took weight HP. I'll take here. That is one variable we took for our previous independent variable. Then we can write here as horsepower of the vehicle. Okay. Okay. Yeah, there's some spelling mistake. Label spelling is LEBEL. I just did. Okay, done. So now let's run this code now. I think I will take three variable only. Table1, Okay, and then we can type here table 1. Okay, and then open the bracket, put tilde sign. Okay, mpg, that is was your first variable, plus remember weight, plus we have horsepower, weight plus HP. I'm going to take it here, the another independent variable. Okay, and then give space here. You can put one shift this single line. Okay, am comma data is equal to empty cars, and just you can get this output. I think you're on the right side. I think you must have got this output. I'll just zoom. You will get the output like this. Clear? Are you getting the output like this? I'll just show you the code here. So look at the output, how it is created. Now just we'll read this output and try to understand what exactly the R has given the output. So mean is this is the mean value. Okay, I'll show it on the right side. Mean 17.1 with standard deviation of 3.83. When n is equal to 13 and overall n, if I took 32 observations, what is the mean? And then what is the standard deviation? Median, this is median value at 0 and at 19th observation. Then n 13, if you see the median value is 22.8, the minimum is 15 and the maximum is 33.9. That is a miles per gallons variable, that is the output, and followed by overall you can see this is for three variables. Clear everyone? Are you getting the output? Or shall I share the code?
Got the output, sir.
Got the output. Okay, got it. Fine, good. Janvi also has got. Nitya. Okay, good. Viba. Right. So these are the ways of doing this particular observations. Okay, where we have many ways we did for doing the descriptive statistics. You can use your own analysis way, and then based on that, we can run the particularly for your data, whatever the ways you are expecting the result, that way you can present it. So, am I clear with this concept of descriptive statistics, how we running in different ways? Hello?
Yes, sir.
Shall we move on to the next one, or should I wait to complete this one? Okay. So shall I, next topic, I'll go to the Excel and just write it here for my understanding here. Is the Excel is visible?
Yes, sir.
The next topic we'll discuss the test for normality that we are going to discuss in now. Let's see how to do the normality testing in R and how do we run that particular this concept of normality. Okay. So as I told you in the previous session, normality means we are talking about the normal distribution. Okay. We are talking about the normal distribution of the data. So this is your normal distribution of the data, whether the data is normally distributed or not. Usually we call as bell-shaped curve, that particular uh, normal distribution. Basically, it's in ordinary language, it is called as bell-shaped curve, but it is called as Gaussian distribution. The real name of this is called as Gaussian distribution. The person who described this particular information on normality. So when we talk about Gaussian distribution, how do we do the normality of the data? As we discussed, there is a technique available to do normality. So there is something called as uh, log transformation technique. So this log transformation technique, what it does, if your data is not normally distributed, right? So it will, if you calculate the log values for each individual observation, you can convert that into something called as normal distributions. So in statistics, when we run something called as parametric test, okay, there is a concept called as parametric test and non-parametric test. Okay, so when we say parametric and non-parametric test, what it deals with basically, let's try to understand that one. So when we say parametric test, okay, it is PARA. So when your data is normally distributed, okay, when your data is normally distributed, we apply something called as parametric test. Okay, so if your data is not normally distributed, okay, then we apply something called as non-parametric test. So there is non-parametric test. So let's try to understand the concept of, it need not to be that always the data should be normally distributed, but that is one kind of assumption that your data is normally distributed. Apart from that, there is no particularly concept that it's always to be a data is should be normally distributed. When you talk about any time series data, it won't be any normally distributed the prices. Okay, so basically, there is something called as we need to understand how do we test this normality, how to do the test of normality. Okay, test of normality. For that, I told you in the previous session, if you want to test the normality, there are two ways. Is there one is something called as graphical method of testing the normality. Graphical method is there, and the second one is something called as statistical method, or we call as empirical method for testing the normality. When we talk about graphical method, we have something called as QQ plot, which is used as one of the graphical technique to describe the particular the data is normally distributed or not. That's called quantile plot. And we also use something called as median technique to understand whether the particular or any kind of measure of central tendency data MOCT method for describing those parameter. But that comes under your empirical method. But graphical, let's understand by taking the quantile plot is one way of understanding the data is normally distributed or not. Empirical method is something called as statistical method also in the, okay, this method which like for example we use a measure of central tendency as one, and then you have something called as skewness kurtosis and normal distribution concept, right? So there we check with the help of those particular method whether data is normally distributed or not. Then once we do, either way you can run through either graphical or empirical, but sometimes it's very difficult to understand through graphical method, particularly whether data is properly distributed or not. So for that we do testing of those particular data by taking empirical method. So for this we need to understand there is something called as assumptions of for this normality. We say whether it's assumptions you can say, or we can say let me put it as hypothesis testing for this particular data. So when we talk about assumption of normality, the one assumption of normality is data is normally distributed for any kind of statistical analysis if you're doing. So We can do this first testing of normality, then we can do any other method. So we can also say something kind of is hypothesis testing over here. So we have two types of hypothesis. One is something called as null hypothesis and alternative hypothesis. So when we talk about null hypothesis for normality says that the data follows the normal distribution. Okay, the data follows the normal distribution. That's a null hypothesis. But alternate hypothesis says that data does not follow, okay, does not follow normal distribution. So these are the two uh, hypothesis, we can say null and alternative. Basically, rather than hypothesis, I would like to say these are assumptions that whether the data follows the normal distribution or data doesn't follow the normal distribution, right? So based on this, we are going to apply this one and check it whether it's really applicable, data is properly distributed or not. We'll run this particular parameter test in the R studio. Clear, everyone?
Yes, sir.
Shall we move on to the next one? Hello?
Yes, sir.
What about others? Any doubts here?
Yes, sir.
Okay, so let's go to the R and we'll work on one data set. Okay, so let's take it one data set. There is a data set called as, I think we have CO2 data set. Just let me say, just type everyone data set and just take CO2. Yeah, C is capital here. CO2 data set. Just run this one. Okay, and then you will get this kind of data set. Yeah. So you can just type dataset CO2 and let me show you the description of this data. What does this data talks about? Okay, just let me type in the help box CO2. Okay, now I think you can check it here. This is what this data is talking about. So CO2 is nothing but this data name is carbon dioxide uptake in grass plant. Okay. So there are different varieties of grass plants are available here. And from this particular grass plant, how much is the uptake of this particular carbon dioxide? So the CO2 data frame has 84 rows and 5 columns. So it means there are 5 variables and 84 observations are available of data from an experiment on the cold terrains of the grass species called as Echinoclorus galli. That is a type of grass variety, and this is the format of that data. You can see here this, you can just, if you go up and check, there is a something called as plant. This plant is nothing but it has an order factor with qn1, qn2 and qn3 and mc1, which is a unique identifier for each plant. They have given assigned number, that is qn1 and followed by mc1 and qn2. Then what is a type is given a factor with levels. Okay, so Quebec, Mississippi giving the origin of the plant. Okay, this is for common, and Quebec and Mississippi, there are two types of plant which are, or we can say grass for that particular matter. And this is a treatment. What type of treatment is required for that particular grass, or we can say plant, with the level of whether it's a non-chilled, whether it is suitable, or chilled, whether it is suitable for that particular plant they have given. So you can see some are non-chilled and some are chilled here. And then you have something called CONC. It's a numeric vector of ambient carbon dioxide concentration level, that is ml per L. So how much level of carbon dioxide they are taking, the vector, that's information they have given. Then uptake is a numeric vector of carbon dioxide uptake rates. So how much is a per we can say per mc square second, what is the number of level of carbon dioxide rates they have intaking by each plant, that is what they are given here. So this is your uptake, which is one kind of for me it is a dependent variable, and then followed by conc is one of my independent variable I can consider. Yes. Okay. So you can just go on and you can check it here because this is from the source, from one of the journal called as Ecology, and this paper is written by these three author in the 1990, right? The source of the data. It's a practically they have work on this data and they have considered this particular plant, what type of climate and what type of concentration and uptake level they have each plants. Okay, so let's do one kind of normality of this particular data, whether it is data of this plant is normally distributed or not. So let's run this particular code over here. So let's first you run this code called as attach CO2, and then you take it, open the brackets, you control enter. Then let's run some test which is related to normality. So first let me go through with the concept of this particularly statistical method I'll show you, and then I'll show you something called graphical method. Both way I will try to just explain you how this normality concept works over here. So attach you can done, and then okay, let me show you first the form of graphical. So you can write as QQ norm, and then you can just take it as uptake. You can take bracket open, control enter, and then you will get the graph on your right side. This is your quantile plot. You can just zoom and just check it. This is how the graph length is there. These are the observations which is look like some kind of a sigmoid curve. Okay, which starts from the -2, then you have minus from -3, -2, and -1 followed by, and then it is go on to the on your positive side. So this is one kind of a distribution of this particular data. Okay, are you getting everyone?
Yes, sir.
Yes, sir.
Uh, are you understanding why we are plotting normal QQ plot? What is QQ plot? Can you tell me what is QQ? Hello?
Quantile and quantile.
Yeah, it's a quantile plot. So just try to understand. So that graph will tell you how the distribution of data is. Okay. But remember, you have studied all of us regression concept over here. So when we do in regression, you have something called as trend line over there. So here also we need to understand whether the trend line can be drawn or not. So that you can just understand from this particular example. This is a distribution, but if it is a line is there, that will be clearly understand how the trend is happening in this data set. So for that, I will type it here QQ line. Okay, just type QQ line and type here uptake in the bracket. Okay, just take bracket uptake, control enter. I think you get this particular line and just zoom. I think you will get the graph over here. Can you see one line? You got it here? Did you got everyone? Just
Yes,
let
sir.
me know.
Yes,
Nit
sir.
Nitya, Janvi.
Sir, can we use histogram instead of normal QQ plot to know if it's normal?
Yeah, we can check it. Just let's see. Hist, I'll put it here. Uptake here. And just open bracket. I'll just close it here. You can see this one. So now both the ways you can do it. So for example, if you see this histogram, it's what do you think? Is it a perfectly normally distributed or what? Or it is not normally distributed?
Not normal.
not normal, right? So the same way we can also do in case of QQ plot also. There also we can understand by the whether it's not normal, because if I draw the curve in bell shape, I don't think so it is fitting every year, because it's not properly distributed the data over here. So that is one thing we can apply here. Both the ways you can check it here. Are you getting everyone?
Yes, sir.
Okay. So let's do another way. We can type here QQ line. Okay, and just take it here uptake. That is one variable, and then take we'll draw the color is equal to 3 and length width, okay, is equal to 3. I'll take it here and then press Control Enter. So let's see for this particular graph, did we got any kind of observations? Okay, just let me run this one and then we can run. Okay, so I think you will get this one. You got earlier it was a black line, but now this time I have taken the green one. You got it? Hello?
Sir, code got executed, sir, but I did not get the results.
Okay, so what you can do here, you just rerun this code 169 and then directly run 171. After 169, you run 171. Again, you run that code. Got it, everyone?
No, sir. In console, I got it in blue, sir, but I'm not getting the graph this side plots.
Okay, okay.
Graph is not executing, sir.
You can make it small, this size. What you can do, this QQ line, you run this code once again, QQ line and bracket uptake, and just run here, click run.
I did it twice, sir, but still I didn't get the graph. Only in console part I got it in blue.
Okay. Is the same issue with everyone? Chetan sir?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Fine. What you can do, can any one of you share your screen? Okay, Viba, can you share your screen?
Yes, sir, I'll share it.
I'll just stop it and you can share it. I'll allow you to share. Okay.
Yes, sir. Yes.
Yeah. Now you can share.
Is it visible, sir?
Yeah, now it is visible. Okay. QQ line. Okay. What you do, you come to your graph side.
Yes,
There,
sir.
can you see left arrow? Left arrow, can you see on the top blue color? Zoom, next to that zoom, there is a blue color arrow is the left side.
Yes, sir.
Can you click on that left arrow on your zoom? No, 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 not that one. Arrow, left side arrow.
That's all, sir.
Okay. Now what you do, you run this code once again. QQ
QQ
line.
line, sir.
Yeah, QQ line, you run that code once again. Click just run. Okay. And now you run 180 code.
I didn't get it, sir.
You got it now.
Now I got it, sir.
Yeah.
Now I got it here.
Everyone understood what you have to do here?
So that graph should be visible, whatever the code we are
Yeah.
I got it, sir.
Yeah. So you can stop sharing that
Yes,
one.
sir, I did it.
So I'll just go R Studio and Excel. What about Nitya?
Yes, sir. I had changed my settings in the first. Like you can use PARMF row. That time you can fit it.
Hmm.
So if you use that like that code, it works.
You got that same one
Ha,
graph?
yes.
Okay. What about Janvi?
Got it.
Okay. So let's go to the next one. We'll run ggplot. Let's see by using ggplot how we can do. Just type this code ggplot2. Okay. And you can just run this package. Okay. Install.package ggplot2 and then you can just run library ggplot2. You can see here. Done.
Yes, sir.
Okay, so now just run this code qplot. Okay, then just open the bracket, sample is equal to uptake. Okay, just run this code, open the bracket, then data is equal to CO2 of two brackets. Yeah. Qplot bracket open sample is equal to uptake. What data is CO2? Just you can run this code and just check it. Did you got like this graph? Hello.
Got it, sir.
How about others?
Got it, sir.
Nitya has got okay.
Got it.
Got it.
Yeah, perfect. So now let's do the exploration of distribution of variable by factor level. We can do it. Let's do it. Qplot. Okay, and then you can just take sample, the same thing. Sample is equal to uptake. Okay, comma data is equal to my data is CO2. Then I'm going to put color for this one. So you can use colors. Okay, see. Okay, and color is equal to factor, then bracket treatment. Let's see what we got this one, and you will get to know. I think there are two types of treatment we are giving: chilled and non-chilled, right? You can just see this graph. Did you got like this graph? Hello.
Got it, sir.
Okay. So what does it mean? What is this color represent here? One is non-chilled and one is chilled. Orange, you can see non-chilled, and here some kind of blue type, you can see that's a form of chilled. So there are two treatments is given. You can see in this data set, right? Is it clear?
Yes, sir.
Okay, I just want to tell you one thing. Okay, just observe this graph. Now, what I want to say, how do you understand from this graph whether the data is normally distributed or not? So by QQ plot, okay, quantile plot, but histogram also you can understand by easily. But how do we understand through QQ plot? If suppose this is a one line which is dividing that entire observation, you can see in some are in negative and positive over here. So if that observations are falling on the line, all observations are falling on the line, so we say the data is normally distributed. But for from this graph what we can see, this observation are not, all the observation are not falling on the line. Some are going beyond and some are attaching to the line, they are close to the line, some are not close to the line. It means that is not normally distributed. Clear?
Yes, sir.
So let's do now statistical measure by taking one test we have, that is something called as, just type here, Shapiro-Wilk test. Shapiro-Wilk test, which is used for normality. So let's type and check whether we can able to do or not. Just type Shapiro. Okay, I just sure. Shapiro.test. And what is our dependent variable? We have uptake, that is our, just type this code 177, control enter. Did you got this result?
Got it, sir.
What about others?
Got it, sir.
Everyone, what about Nitya, Janvi?
Got it,
Yes,
sir.
answer. Okay, now let's try to. Now you tell me, please. You can answer any one of you the this particular question. When I'm running Shapiro dot test uptake, I'm getting this particular result. So tell me whether it is a form of graphical or empirical.
Empirical method.
It is an empirical method, right? So it empirical is nothing but we are talking about the statistical method, which is nothing but testing of the normality by taking Shapiro-Wilk test. Okay. So now let's do it and understand that values. So let me go to this one. I just want one very important value here, that is your p value. I'll just copy and paste it in my Excel. So this is my p value of my dv. My dv is a pick. So now let's try to understand what is our null and alternate hypothesis. There is something called rule of thumb, okay, to decide whether to accept or reject for this particular hypothesis. So let's imagine you can form the level of significance whether it is a 5% or 1% based on your understanding. But usually in social science research, normally if you see any kind of social science research in terms of finance, marketing, HR and all, they will take it as 5% of significance level. In case of medical research and all, they will take up at most 1% of significance level, right? So there are two ways. So let's assume we have taken at 5% of significance level. So my level of significance is, so I will write it here, level of significance. I'm taking 5%, which is 5% is as good as, for me it is 0.05, okay, to decide whether to accept or reject the null hypothesis or alternate hypothesis. So what is the rule of says, if the, what is the rule of thumb? Okay, very important note, I'll write it here. If the p value is less than 5%, then we should accept the alternative and reject the null hypothesis. I'll just write it over here. If the p-value is less than 5%, then accept the alternative and reject the null. And same way we can do vice versa. If the p-value is more than level of significance, that is 5%, then we should accept the null and reject the alternative. So this is the my very important note. Okay, so in short, what we can say, if it is less than 5%, accept the alternative. Reject the null. And if it is more than 5%, the level of significance of error, then accept the null and we can say reject the alternative. Understood? In short, this is what we have to do to accept or reject the hypothesis. So it means what? I'll take it this one as 1 and this is as 2. Okay. So now you tell me what is our p-value of uptake? How much it is? 0. 0.007908, right? Shapiro-Wilk test p-value. Am I correct? Are you getting everyone what I'm trying to say here? Hello?
Yes, sir.
What about others? Are you there?
Yes,
Yes, sir.
Yes, sir.
Okay, so what I'm saying, the Shapiro-Wilk test p-value is 0.007908. Tell me whether this value it is less than 5% or more than 5%.
Less than
Yes.
5.
It is less than 5%, right? So if it is less than 5% means what we should do? We should accept the alternative and reject the null. So what is my accept the alternative? What is alternative? Can you see here? Data does not follow which distribution? What is this? Data does
Normal.
not follow, yeah, data does not follow normal distribution. If this value could have been more than 5%, then I could have accept null, which says data follows the normal distribution, right? So now you tell me, how did you confirm this one? By taking statistical method, that is through Shapiro-Wilk test. Okay, and this test will tell you whether it is a normally distributed. Now that's an assumption whether my uptake is dependent variable and that is normally distributed or not. So we can say our data is not normally distributed. Since the p-value is less than 5%, we are accepting the alternative. Remember, in case of this is assumption of normal distribution, but usually null is like a negative statement and alternative is like a positive statement. This may not be the same case in every time. It's depend on your hypothesis. Okay, what exactly your objective is, whether you want to prove alternative or whether you want to disprove null. So based on that, you are going to frame your hypothesis statement. So remember, based according to that, I have prepared my hypothesis statement here. So that means uptake, which is nothing but this particular, we can say variable. This is your uptake. Okay, just I'll go to here. This particular uptake variable is not normally distributed. So we got confirmation through Shapiro-Wilk test. Okay. So we can do it in other way also. We have one more package called as NOR test. Just we'll run this package called as install.package called as NOR test. You can just run this one, NORTEST. Just you install this package, NOR test. Let me install this package, nor test. Okay, then you can just run this code called as library, and then you can test nor test. You can just run library nor test. Okay, now let's run this one. There's one more test is this that's called as Anderson-Darling test. So we say ad.test. Okay, so ad.test, which is nothing but for uptake, I'll take it that my dependent variable and just press Control Enter. Again, you can see here this Anderson-Darling normality test. Okay, this is one test which is used for taking the normality. So I'll write it here. What are the tests using for testing? Test used for normality. So we have something called, first one is Shapiro will test. That is one test we are using. And then second one is we are using something called Anderson. Okay, just write it here. Anderson. The person, there are two people, Anderson and Darling. These are the two people who have developed this test for normality. So as we know from this particular test, the p-value is 0.400471. So I'll just write it here. This was the value as per Anderson-Darling test. And then you have Shapiro-Wilk test. P-value is this value. I'll just copy this one and paste it here. So this was the value as per the Shapiro-Wilk test. So both the test confirms that p-value is less than 5%. So we can say accept the alternative. When we say accept the alternative means data is not normally distributed or data does not follow normal distribution. Is it clear, everyone?
Yes, sir.
Yes, sir.
Any doubts till now?
Sir, which do we prefer, like graphical or empirical, if we are given only one option?
We'll use statistical method, that's more accurate, because when the reader or anyone reading that particular, no, whether it is statistically proved or not, we have to first define. So graphical is just an data spread, it is showing observation, but tests are proved, right? These are proved tests. That is the reason we'll use test as per the statistical method only. Clear?
Sir, yes.
So these are two tests I taught you here, and one more thing which I want to teach you, very important here is, so just I hope, shall we proceed further? Okay, please come to R and I'll teach you one more concept, very important. There is one more test is called Lilley-Ford normality test, that is also there, but I just want to take you for a moment to understand how we can use the skewness value to test the normality. Even that also can be used. So just to run this code, I think those who were not there yesterday, did you install this package called as Moment? Install.package called Moments. I think in recording it is available. You just run this code, install.package called Moments. And then you just run this code, library moments. Just run this code.
Done, sir.
Done. Okay. Now what you do, okay, just follow me, everyone. I'll just very important concept I'll teach you. How skewness is very important in our statistical analysis. Just type skewness. Okay, just skewness, and my dependent variable is uptake. Just type skewness and dependent variable is uptake. Now, did you got this result, this value?
Yes, sir.
What about others? You can raise your hand or you can just tell me whether you got minus 0.1059413.
Yes, sir.
Okay. Now let me just copy this value and let me go to my Excel sheet and just I'll take it here. Skewness importance in distribution. Okay, my skewness value is somewhere 0 point minus 0.10593. Okay, first of all, you tell me how many types of skewness we have.
3.
2 types.
Okay, two, three. Three are curtices. There are 3 types of curtices and 2 types of skewness. One is positive skewness and one is negative skewness, correct? Nitya?
Yes, sir. Sorry, I got confused.
Okay, and curtices are 3: mesocurtic, platycurtic, and leptocurtic. Now tell me the skewness, okay, this is for what is my dependent variable? Uptake. The skewness for uptake is positive or negative? This value, this is negative,
Negative, sir.
right? Now, if the skewness is negative, it means what we say? Negative skewed, right? Simple meaning is what? It is negatively skewed. What? Your dependent variable. So, in your distribution, what do you mean by in your distribution? Just I'll try to explain here. Okay. Just think here. In your distribution, okay, when we say distribution means I'm plotting this graph. Okay. What is this? I'm talking about Gaussian distribution. Okay. This is your mean. Okay. So it means it is negative distribution, right? So it means what? What do you mean by negative distribution? This is normal distribution. Okay. I'll write it this as ND. This is normal distribution. Okay. Then what is negative distribution? The moment when we say negative distribution means the left tail is longer. Okay. What is tail here? This portion of the data. Okay. I'll keep it here. This one and this one. Okay. So let's imagine if this is 95. Okay. If this is 95, then this will be 2.5 left side and this will be 2.5. Okay. 2.5, 2.5, how much? 5. So entire 95% of the observations are falling close to the mean value, right? So now let's imagine the other side of the graph here. What I mean to say, negative skewed, the left tail is longer. So the left tail means the tail will be like this. Okay, it will be like this somewhere. So it means what happened?
Sir,
So,
it is.
hello?
Sir, this is positive discussion, sir. Right side is.
Oh, sorry. Left tail, I got confused from this side. This one side, sorry. I'll just delete 1 second and draw it here. I'll just take it there. Where it went? Let's draw it down. Okay. Yeah. So it means left tail. What is left tail here? Okay, this is just try to understand from this. It is like this. So it means what? Whenever the data is negative skewed, means your tail of your left side, this side, this is your left side of your tail is always longer than your right side of the tail, right? So this is called negatively skewed. So how does a positive skewed look like then? Just the complete opposite of this one. So I'll just put it here again. So it will be somewhere like this. Okay, just excuse me on this particular graph, but you try to understand. Tails are deciding the distribution, whether it's a positive skewed or whether it's a negatively skewed, how far the skewness data is being skewed. So it means what? Now here we have the skewness value is minus 0.05, which means that data is negatively skewed. And so the uptake variable does not have any kind of normal distribution. So our data is this one. So our uptake is here. This is your uptake. Okay. So this uptake is not following any kind of normal distribution. So this is not normally distribution. One way is through understanding of skewness value. What should be the ideal normal distribution? It should be like this bell-shaped curve. Not even this right side of the tail also. That also should be not considered as normal distribution. Is it clear? Hello?
Yes, sir.
Yes, sir.
Okay. So I'll just delete this one. This graph. So you understood? We can use with the help of what? Skewness also to decide whether its data is normally distributed or not. Any doubts here till here? Got it, everyone?
Got it.
Yeah. So can I take till 8:15? Not issue. Just 5-10 minutes.
Okay, sir.
Sure, sir.
Yes, sir.
Okay, fine. Let me come back to my Excel sheet. Let's discuss the concept of hypothesis testing. So let's try to understand hypothesis testing concept here. Suppose, for example, as I told you here previously, that we have two types of hypothesis. One is your null and alternate. I think we have written here. Yeah. So this is your assumption and this is your null alternate. So when we talk about hypothesis testing here, so let's imagine, for example, I'm writing here one statement. If you want to compare the any difference, or we can say any kind of significant difference, okay, significant difference in the mean of the two components, okay. You want to compare the significant difference in the mean of two component, or when I say component means I'm talking about component is referred as data set, okay. It's referred as data set, right? So what we do basically, if you want to compare the significance difference between the two data set, you have type of test, one something called as Z test, okay, and you have something called as T test, okay. So when we use Z test and when we use T test, okay, so let's try to understand first Z test concept here. Your Z test is used when the standard deviation, okay, of the population, standard deviation of the population is available. Right? In case if there is no standard deviation of the population is available, then we use something called as t-test. So when we use t-test, it is used when the standard deviation of the population. Okay. When the standard deviation of the population is unavailable. Try to understand two concepts here. Right? So what we uh, mean by population and what do you mean by sample, as we know? So first concept comes from universe, which is infinite. Population is finite. From the population, we derive something called a sample, right? So you just understand the concept behind these two concepts. When you're comparing the significant difference in the mean of two data set, right? So the what is the one thing either you should know what is the standard deviation of the population, or you should know what is the standard deviation of the. If you don't know, then what you should apply here, right? In case of Z-test, okay, the basic assumption in Z-test is sample should be drawn from normally distributed population, right? So very important is in Z-test, when you are doing any kind of Z-test, the basic assumption is, okay, the basic assumption behind Z-test, okay, when we use Z-test, when standard deviation of the population is known or available, we say, in Z-test, the basic assumption is the sample should be drawn from normally distributed population. And the standard deviation of the population should be what? Known. That is where we use something called as what? Z-test, right? So that's the concept of what? Z-test as well as what? T-test. Okay. So based on this one, so first what we should do, the very first step in hypothesis testing is you should set your null and alternate, right? So you should know what is your H0 and H1. You should, if you set that one, then you can do further analysis. Then with whether your H0 is based on your study, you have to define what is your H0 and then you have to define what is your H1, right? Which is called as null and alternate. Once you set what is your null and alternating, okay, this is your step number one, we can say, in doing hypothesis testing. The second step is you should define the significance level. I was talking about the significance level, no? So what is significance level? Either it is 0.01, 0.05, or either it is 0.01. So you should, second thing, you should define your significance level, right, in your research. Once you decide null and alternate, then you can go ahead with the calculation of significance level. It's a 5% or 1%. As I told, social science research mainly deals with 5%. Most of the medical research will go ahead with the concept of 1% significance level, or you can say the error margin, they will keep it very less over there, right? So for example, if you're taking one test, for example, I'll discuss one test. There's something called as one sample t-test. Okay, one sample t-test. This is one kind of a test. When we use this one sample t-test, okay, when we want to check the mean score, right, the mean score of a sample is what compared with mean score of the sample is compared with known population. Known population mean. So sample mean is compared with population mean. In simple language, that's the meaning of one sample t-test. Now, so if I want to run this one sample t-test, okay, so again what I have to do, I have to frame my null and alternate hypothesis. So my H0 in this case, my H0 will be, I'll write it here, me. Suppose for example, I'm taking the same data set we have taken that called as CO2, right? So let's say if I'm putting the mean is 30, I'm telling that the H0 is 30, then H1 I'm defining as mean. I mean, H0 means the average is 30. The H1 I'm telling that mean is called as average. is not, it is not equal to 30. It is not equal to how much? 30. Now I'm set my null and alternate, right? So what is the second step now? Once you set H0 and H1, then you have to set what is your significance level. So we'll keep it how much percent? 5%. So I'll just highlight this text as 5%. So what I'm saying, the average of the uptake, okay, which is my dependent variable, is equal to 30, and the alternate I'm saying, which is not equal to 30. So now I should prove whether H0 is correct or H1 is correct by doing one sample t-test. It means I am testing the average score, mean sample score is compared with population mean, right? So that we need to do in R, and let's do it with the help of this code. Okay, just type here. Okay, so I am doing here something called one sample t-test. One sample t-test. So what I will do now here, I'll run this code t.test. Okay, just type this t.test all of you and type here uptake, which is your dependent variable, comma, mu. Mu means what? The mean value is equal to how much I am telling, defining equal to 30, right? Just type t.test bracket uptake, comma, mu is equal to 30, control enter. Okay, now let's see. Can you see here? This is which test I am doing? One sample t-test. Okay, now I need to understand here. This is your t statistic value, that is minus 2.3619. Usually it is from the range of 1.96 to negative to positive. This t statistic value 1.96 to minus to plus. DF is called degree of freedom, 83 is the value, and P value is 0.2052. Okay. So what is alternative hypothesis? True mean is not equal to 30. See here, the R has given the statement itself here. Okay. So now what I'll do, this is your mean score of the X. So when I'm saying many things you can do from here, one by one, I'll take the value first. Okay. I'll copy this one sample t-test value. So I'll just go to my Excel. Here results of one sample t-test. Okay. Results of one sample t-test. First thing, I'll copy my p-value. This is my p-value. Then second thing, I will copy what is my mean of the x value. That also I'll copy here. This is the mean of the x value. Okay. Now let's try to understand. First thing is you should accept or reject based on your what? P value. Okay. First you decide whether this P value, this value, it is greater than or less than 5%. Tell me, everyone. This P value, which is 0.02052, is it greater than 5%, which is called 0.05, or it is
Lesser,
lesser?
lesser, sir.
It is lesser, right? So it means P value is less than 0.05. Correct, no? Right? Now you tell me, when P value is less than 0.05, what we should accept and what we should reject. What we should accept, what we should reject. Hello?
Reject null hypothesis.
Reject null hypothesis. Okay. Good. What about others? Yeah. Let's go here. P value. Tell me, our P value is how much? 0 point, which is less. So less means we should reject the null and accept what? Alternative, correct? Chetan sir? Hello? Janvi? Vipa?
Yes, sir.
Yes, sir.
Okay. So now our p-value is less than 0.0. So we should reject the null and we should, so based on my result, accept the alternative, correct? Now, what is our alternative? How? This one. So mean, this is x, right? Mean of x means this value, right? Is it mean of x or not? What is the mean of x? 27.2131, correct? No? Hello?
Yes,
Yes,
sir.
sir.
Yeah. So mean of x is 27.2131. So now you tell me mean of x, is it equal to or not equal to this 30? What we said? Mean should be equal to 30, right? But our mean of x, is it equal to 30 or not equal to 30?
Not equal to 30.
So we can say mean of x is not equal to 30. Correct? So when mean of x is not equal to 30 means obviously my alternative hypothesis is accepted. So this 27.21, we can write like this, 27.21 is not equal to 30. I can write like this also, right? It is not same, no? So there is some deviation is there, no? What is the deviation? So if you take 30 minus 27.21, the deviation is around 2.79. Am I correct?
Yes, sir.
Yes, sir.
So there is a deviation of 2.79. Obviously, it is not. So we accept the alternative hypothesis based on this result. Understood, everyone?
Yes, sir.
Yes, sir.
Okay. So let's stop for the day. Today's this one. And we'll continue from